Welcome to 6.02b homework walkthrough video. Let's get right in. Julian's basketball team played 13 games this season. The histogram shows how many points were scored in each game. Okay, so this histogram is a bit confusing because it's like what number is with this middle bar, right? Got all. Also, doesn't really make a lot of sense. If we're just judging the histogram on merits, and Julian's basketball team's pretty mid. Because, like, what? 6 games, only scored 13 points? Come on. Come on. Based on the plot, determine the most appropriate measure of variation and why. The most appropriate measure of variation for the data set is, check those two options, because the data does or does not contain an outlier. Well, let's answer this box first. Does the data contain an outlier? Yup. Yes, it does. It contains an outlier. If there is, let me start that over. Range is the best way to measure variation when your data is perfect. If your data is not perfect, so if your data is not symmetrical, if there's an outlier, don't use range. Range will just give you a silly answer that will make your data sound different than it is. Range is the best way to measure variation if your data is perfect. Since our data is not perfect, since we have an outlier, we use interquartile range. Yeah. Mr. Pumphrey. Oh, question 2 does change every time. Mr. Pumphrey records the height of each of his 7th grade students and creates a box plot to represent the data. Box plot, or box and whisker plot. Ba, 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 ba. Determine the height of his students. 7th grade, 5 feet. Whoa, not judging his students. Actually, no, that looks normal. Looks like normal height, I guess. 5 feet. Nobody even close to 6 feet, though. Not judging, just analyzing. Determine the best measure of variation based on the graphical representation. Since the data appears, the is inappropriate to measure of variation. So let's see. Answer this box. Is it skewed or is it symmetrical? Looks symmetrical enough. I know nothing's perfect, right? Nobody's perfect. But it looks symmetrical enough. Now, I said it on the first question, I'll say it again. Range is the best way to measure variation when your data is perfect or near perfect. So if your data is symmetrical, if your data has no outliers, use range. Range is best. Not only is it easier to find than IQR, but it's also better. It explains better the variation of your data, but only when your data is perfect. Since our data is perfect or near perfect or looks super clean, we will use range. Question 3. Trina and her family are at Universal Studios. She records the different wait times for some of the rides. The dot plot displays the data she records. Oh, is she going like every ride? Also, some of these feel like there should be some dots up here at 90 minutes. So maybe she went on a busy day, or a not busy day, a rainy day. Interesting. All right, keep reading. Stop getting distracted. Complete the following statements based on the data represented in the line plot. It's a dot plot. Oh, wait, I guess maybe dot plots could also be called line plots. I guess. The most appropriate measure of variation to represent the ride wait time is the, since the plot appears to be. So let's answer this box. Is the graph symmetrical or skewed? Well, it's not perfectly symmetrical, right? But it's fairly symmetrical, I'd say. From this dot to that dot, it's fairly symmetrical. And just like in question 1, just like in question 2, Range is the best way to measure variation if your data is perfect. If there's an outlier, don't use range. Data is not perfect. If your data is skewed, meaning not symmetrical, don't use range. It's not perfect. So since it is perfect, it's fairly symmetrical, we use range. Question 4. The data set shows number of tickets at a local amusement park sold every day for 12 days. Oh, what happened this day? 200, 300, 200, 200, 300. Which value could be considered an outlier? 646. Right, all the other numbers are 2s and 3s. The most appropriate measure of variation for the data set with the outlier is because the data is. Now, pretty hard to see, right? Wait, I remember this question from yesterday. So, since this drop down should have I think it should have outliers or no outliers, is what it should talk about. But maybe if there is an outlier, that means your data is skewed. Maybe they mean the same thing, having an outlier being skewed. Maybe, because since there's an outlier, because what we did on question 1, we know, if there is an outlier, we do not use range. That'll mess up our data. We use IQR because we can't ignore this crazy day where we sold almost 650 tickets. So we just use IQR and kind of ignore it. Still happened, but we just ignore it and find the range of the middle 50%. And since there's an outlier, I guess that means it's skewed. Yay! Question 5, last question alert. When is interquartile? Let me take a snip of this so I can draw. Love drawing on multiple choice. When is the interquartile range considered to be the most appropriate measure of variation? When is interquartile range the most appropriate? So when is IQR most appropriate? When so IQR is when the data is bad. When the data is not perfect. Range, change green, range is when the data is good, when the data is perfect. Range is better than IQR if the data is good. If the data ain't good, then you use IQR. If the data is bad, you use IQR. Little worse way to say variation, how your data varies, but data is not perfect. So when your data is not perfect, you use IQR. When your data is perfect, you use range. So which one of these options is talking about data being bad? The data being not perfect. Bad data. Good data. When there is no outlier. No outlier means it's a good thing, which means this would be a range option. When there are extreme outliers present in the data. So when there are outliers, that's a bad thing. That means you got bad data. Or ugly data, I should say. Not bad or good, just ugly data. Let's keep going though, just in case, because I think it's B, but let's keep reading. When there are too many values, nah, that doesn't have anything to do with it. That has nothing to do with nothing. When the interquartile range is never the most appropriate, nope. Sometimes it is. Sometimes it is appropriate. All right, looks like our correct answer is B. Thanks for going with me on this crazy ride, folks. We are done with this homework. If you have more questions, though, or there's ideas you don't understand, send me a Canvas message. Come to my homework help time. I'll be glad to help. All right. Goodbye. Good luck.